So we go to question number 6. Right. Ini agak panjang sikit jalan kerjanya. As usual, before you do the programming straight away to the MATLAB, you need to really understand what is this all about. In this case, it states that you need to provide the transfer function of this circuit and plot the response, the circuit response by using MATLAB. Okay, so in that case, you need to do the analysis first before you go to the do the programming. How can you do the analysis first? That's why you need to implement the SDM method in the programming. So the first thing is you need to know what is the requirement of this program. So the requirement of this program is state that you are given with the figure. This figure has it state that this one can be solved by using Laplace transformation. Okay, so it states here that in Laplace information, you need to transform R to R, L to SL, and if you have in the circuit the capacitance, you need to transform the capacitance by using this formula 1 over SC. Okay, so after that, after you do the transformation by using this transformation, then you need to convert the circuit, okay, by using voltage divider rule. Okay, this is the ni silap tadi kita dah ubah formula ni lah VO, V output equals to S over S plus 1 times VI. Okay, yang ni dah dibetulkan tadi kan. Sekejap ya, saya tengok kat sini. Yes, dah dibetulkan. Sekejap saya tukar supaya dia tak confusekan kamu. Okay. Alright. So this is all the given information. The first step is requirement specification. So you know that there is you need to do the transformation by using Laplace. So then you need to do the calculation by using this formula. Okay. In order for you to get the transfer function, then you need to modify this formula to get the transfer function. Right. So based on this circuit is actually you will have this as R1. Okay, this is R for this, while L is SL. So here, okay, here S is SL, right? Okay, this is your VI. So ni adalah VI. Right. So based on this figure, figure 3. Oh, sorry. This one better I put it there. Sekejap, better I put it here so that, okay, this is R. This is SL. And should be this is VI. Okay, so that you can relate the Laplace transformation here, the equation here. Okay, so based on this, then you can compute the output voltage by using a voltage divider rule, where the voltage voltage output is S over S plus 1 VI. Okay, as you can see here, the SL is changed to S. Okay, S is represented by SL, 1 is for R. Okay, so so kalau kita ada formula macam tu, right? So voltage in SL, okay, voltage in SL is actually SL is divided by R plus SL. Okay, as voltage in SL in this area is actually is SL over R plus SL. Okay, so this must be multiplied by VI. So this is the equation. So by having this equation, you can simplify it. Okay, you can simplify. So this is actually the output is SL over R plus SL. Okay, VI. So in order for you to get the transfer function, so the transfer function is VO over VI. Okay, so this is VI, you must put it here. So now you get the SL over R plus SL. Okay, since the SL is here, sorry, since the SL is S and R is 1, so we can rewrite this one VO over VI. SL is S over R is 1 plus S. Okay, so this is the transfer function for this circuit. So this is the new equation to get the transfer function. Okay, so in the MATLAB, okay, in order for you to get the response, the circuit response, you must use frag S function. Okay, in this frag X function, it requires the numerator and numerator. Okay, numerator coefficient and numerator coefficient, right? So this as you can see here in the code, okay, in the code it provides you with the B equals to 1, 0, A equals to 1, 1 again. So this is in the MATLAB. Why? Why it provide you with this value B equals to array 1, 0 and A equals to 1, 1, right? Because here the S is represented by B. Okay, 1 plus S is represented by A. Okay, how can we get the 1, 0 for B and 1, 1 for A? Okay, because of I put the assumption here. Okay, I put the assumption here that the S is the value of S is I. I assume in order for me to provide the calculation, I assume S is 1. Okay, so since the S plus 1, okay, the S is in polynomial, okay, in polynomial, B, since we use B as a representation, so S here is S1 plus 0 S power of 0. While here, denominator. Okay, A here is S1 plus 1 S power of 0. Okay, so based on this, if S is 1, if the value S is 1, the value of S is 1, 1 power of 1 plus 0, S is 1 power of 0, so this is 1, right? 1 and 0. That's why you get it here, 1 and 0. Okay, 1 power of 1 is 1. Okay, 0 times 1 power of 0 is 0. Okay, that's why we get here B is 1, 0. This is where I assume S equals to 1. So, for the A here, since I assume S is 1, so for this part, 1 over 1 plus 1 times 1 power of 0. So 1 power of 1 is 1. 1 power of 0 is 1 times 1 is 1. So that's why 1 and 1. So I got it here, 1 and 1. So I initialize B with 1 and 0, A with 1 and 1. Okay. So in the data analysis, the step number 2, I have the input. Input for this is the value of B and also the value of A. What is the output? My output will be the response of the circuit in the graph. Okay, what is the formula that should I use? In this case, there is no formula because I already done the formula all in manually. Okay, on the paper, and then there is no constraints in my program. Okay, so the algorithm for my program is actually in pseudocode. First, I provide the input value of the B, and then input value of A, and finally I do the plotting. Okay, plot the graph of response, circuit response. Okay, so do in the MATLAB programming, because after you do the third step, which is Argo, then you need to do the implementation. So in this implementation, go to the MATLAB, provide the script over there. Okay, so here you state that the first step is to provide the input of B. Okay, then you need to provide the input of A and do the plotting. Okay, and do the plotting of response. Okay, so you can use code in this. Okay, how to put input B, since we already know the value because we assume S is 1, so I'll provide here the value is 1 and 0. Okay, and then input for A is actually A equals to 1 and 1. Okay, so in order for you to plot the circuit response, you need to use function using freq_s function. Okay, so in this case, freq s B and A. Okay, and save. This is question number 6. So this is the graph that you get from the frequency frac s function. Okay, in frac s function, the response for the circuit is given to you by plotting the magnitude graph and also the phase graph. In the magnitude graph here, you can see the graph here is this is indicate that this is the high pass filter. Okay, the circuit is about high pass filter, and the cutoff for negative 3 dB is actually from here. Negative 3 dB is 0.7. So the cutoff is actually here, which is 1 radian per second. Okay, so in this for the fast response, for the phase response, the value is actually for the 1 radian per second of frequency. Actually, you get the value of almost 45 degree. Okay, like this is response circuit for the question number 6. Right, so you do the same for the question number 7. In question number 7, it provide to you the question number 7, it provide to you the value of S is actually 1 over S, and the value of R is still 1. Okay, so when you do the when you want to set the input value for B and A, when you analyze it, you will get the B equals to 1 and A equals to 1 and 1. Then you plot it by using frac S frequency. Right. So that's all for the question number 6. The same steps you can implement it for the question number 7. Okay. So far, do you have any question? Ada soalan tak?
No, Doctor. Thank you.
Alright. So, kalau tak ada soalan, kita ada berapa minit je lagi sebelum you punya kelas habis. So, make sure just to remind you for the attendance, I will based on the submission at this author. So, make sure you submit it before the class end. Okay, I think that's all for today. Thank you for coming for the class, and hopefully next week we can do the lab number 2. The lab number 2, that one is we will not do it by online. Okay, you need to do it by offline. So please make sure you get the question from the author. Okay, so that's all. Thank you. Assalamualaikum dan selamat pagi. See you next week.
Waalaikumsalam.
Thank you, Doctor.
Thank you, Doctor. Alright.
Thank you, Doctor.
Salam. Thank you, Doctor.
Terima kasih.
Thank you, Doctor.